Far beyond the orbit of Neptune, in a region where sunlight is little more than a distant glow, a lone spacecraft continues its journey into the unknown. It has traveled farther than its creators ever imagined. Built during an era when computers possessed only a fraction of today's processing power, Voyager 2 was never intended to become a half-century-long explorer. Yet decades after leaving Earth, it remains one of humanity's most valuable scientific ambassadors, carrying a message from our world into the vast darkness between the stars. Today, Voyager 2 occupies a realm few people ever think about. It is no longer visiting planets or capturing dramatic close-up images of alien worlds. Instead, it drifts through a region where the influence of our Sun gradually gives way to the broader environment of the galaxy itself. For scientists, this territory represents one of the least understood frontiers in modern astronomy. And the deeper Voyager travels, the more surprising that frontier becomes. The story begins long before the spacecraft ever left Earth. During the 1960s, astronomers recognized a rare opportunity hidden within the motions of the outer planets. Jupiter, Saturn, Uranus, and Neptune were approaching an alignment that would allow a spacecraft to visit all four worlds using gravity as a natural accelerator. Such an opportunity appears only once in many generations. By carefully navigating around each giant planet, a spacecraft could steal a tiny portion of its momentum and use that energy to reach the next destination. The technique, known as a gravity assist, would make a grand tour of the outer solar system possible. NASA seized the opportunity. Engineers designed two robotic explorers capable of surviving years in deep space. Those spacecraft became Voyager 1 and Voyager 2. When Voyager 2 launched in August 1977, no one could predict how successful the mission would become. Its first major destination was Jupiter. As the spacecraft approached the giant planet, scientists expected new data. What they received instead was a revolution in understanding. Jupiter revealed itself as a world of violent storms, immense magnetic forces, and active moons unlike anything previously observed. Massive cloud systems stretched across the planet, while lightning flashes illuminated its turbulent atmosphere. Perhaps even more remarkable were the discoveries surrounding Jupiter's moons. Worlds once believed to be frozen and inactive displayed signs of complexity and change. Surface features hinted at hidden geological processes operating beneath layers of ice. The outer solar system suddenly appeared far more dynamic than expected. The surprises continued at Saturn. Voyager 2 provided detailed observations of the planet's rings, exposing intricate structures that challenged existing theories. Instead of simple bands encircling the planet, the rings consisted of countless interacting particles shaped by gravity and motion. Titan, Saturn's largest moon, emerged as another mystery. Wrapped in a thick orange haze, it concealed its surface from direct view. Scientists suspected that complex chemistry was occurring beneath the clouds, creating an environment unlike any other moon known at the time. Yet Voyager 2's greatest achievements still lay ahead. After Saturn, the spacecraft continued toward Uranus and Neptune, becoming the first, and so far only, probe to visit these distant ice giants. Uranus surprised researchers with its unusual orientation. The planet appeared to roll around the Sun on its side, producing seasons unlike anything found elsewhere in the solar system. Neptune offered an entirely different set of mysteries. Despite receiving only a fraction of the sunlight that reaches Earth, the planet hosted some of the fastest winds ever measured. Enormous storms raced through its atmosphere, demonstrating that even the coldest giant planets could remain unexpectedly active. By the late 1980s, Voyager 2 had completed the planetary phase of its mission. Most spacecraft would have retired. Voyager kept going. Year after year, it traveled farther from the Sun, entering regions no spacecraft had ever explored. Scientists waited eagerly for the moment when it would finally reach the outer boundary of the Sun's influence. That boundary is not a physical wall. Instead, it is a vast transition zone where the solar wind collides with material drifting between the stars. For decades, researchers debated exactly what this frontier would look like. Would it be smooth? Would it be turbulent? Would it behave as existing models predicted? When Voyager 2 eventually crossed into interstellar space, the answers proved more complicated than expected. Measurements revealed significant changes in particle populations, magnetic activity, and plasma conditions. Some observations matched theoretical predictions, while others raised entirely new questions. Rather than a simple border separating two regions of space, the frontier appeared dynamic and constantly changing. Scientists discovered that the environment beyond the solar system was not empty. Instead, it contained electrically charged particles, magnetic structures, and complex interactions occurring across enormous distances. The findings transformed our understanding of how the Sun interacts with the galaxy around it. Then came another surprise. Sensitive instruments detected faint plasma oscillations moving through interstellar space. These signals revealed that the medium between stars is capable of carrying waves and disturbances across vast regions. Far from being silent, deep space possesses its own subtle activity. For researchers, this discovery highlighted an important lesson. The universe often turns out to be more complicated than our first models suggest. Every time Voyager 2 sends information home, it reminds us that exploration is not merely about reaching distant places. It is about confronting assumptions and replacing them with evidence. Today, Voyager 2 continues its lonely voyage. Its power supply slowly declines. Individual instruments have been turned off to conserve energy. Engineers carefully manage every remaining resource to extend the mission for as long as possible. One day, the spacecraft will fall silent. Its transmitter will no longer be able to communicate with Earth, and the flow of data that has continued for decades will finally end. But even then, Voyager's journey will not truly be over. The spacecraft will continue drifting through the Milky Way for millions of years, carrying a small record of humanity into the darkness between the stars. Its greatest legacy may not be the planets it visited or the records it broke. It may be the realization that the unknown begins where certainty ends. And beyond the frontier explored by Voyager 2, countless mysteries still await discovery.